Rising from the seas of Sri Lanka, port city Colombo is a large-scale reclamation and city development project undertaken jointly by China Communications Construction Company, a Fortune 500 company, and the government of Sri Lanka. Spanning 269 hectares, Port City Colombo, when fully developed, will have a total gross floor area of more than 5.7 million square meters. A modern city where people can work, live, and play. Port City Colombo will also be the pioneer.
Welcome to Engineering News Record's 2020 Global Best Projects Awards.
This project is the first step in a bold mission to jumpstart the local economy.
Best Project, Airport, Port. Colombo Port City Development Project, Phase 1.
Strategically located along the 21st century.
I also take this opportunity to extend our sincere gratitude to the Czech Port City Colombo Private Limited for joining in the sustainable journey of the Green Building Council of Sri Lanka. It's no secret that the construction industry has a significant impact on the environment. Construction is responsible for up to 50% of climate change, 40% of energy usage globally, and 50% of landfill waste, not to mention air, water, and noise pollution, and destruction of natural habitats. As the effects of climate change and other environmental issues become more pronounced, it's more important than ever to find ways to protect the environment. So, since it is high time to discuss on climate change and the role of construction industry. To start off the session, I would like to introduce our environmental assertive speaker, Dr. Shanaka Kristombu Baduge. He is a postdoctoral research fellow of the Department of Infrastructure Engineering, the University of Melbourne. Currently, he is the manager of the Centre for Advanced Manufacturing of Prefabricated Housing, funded by the Australian Research Council. He is a climate reality leader of climate reality projects organized and trained by Nobel laureate and USA former Vice President A.L. Gore. His research interests include low carbon and energy efficient building systems, high performance materials and composites, prefabricated buildings, and upcycling waste into engineering applications. His contribution to develop design guidelines and sustainable mixed design for ultra-high performance concrete was recognized by the Concrete Institute of Australia with a Victoria Award for Excellence for Technology and Innovations. He also an inventor of recycled plastic modular framework system for construction, which is licensed to an Australian industry partner. Over to you, Dr. Shanaka. Dr. Shanaka, your mic is muted.
Yeah, so thank you, Situmini, for the kind introduction. And also, as you mentioned, and also you highlighted, the climate change is a contemporary topic, and also it's a high time to discuss. As we know, even the government has taken some initiative to promote renewable energy. We know the reason behind that, because that's the pressure due to the climate change. Nowadays, I think this when we talk about sustainability, there's a trilemma, like the social, environmental, and the economy. Now the environmental, the domain is predominant. It's more powerful because nature is calling for us to act. So let me share the presentation, and also please confirm whether you can see that.
Yes, sir, we can see the screen.
So now can you see the presentation mode?
Yeah,
Can you see
yeah.
that?
Yeah, sir.
Okay. So so today topic, I'm going to cover the climate change and role of building industry. So Ms. Situmini also highlighted the importance and the duty or the role of the building industry, because it contributes to 40% of emission in the world. So it's like a very important sector we have to consider when it comes to climate change. So and also I would like to especially mention Dr. Seong Won Seo. He's a scientist in CSIRO or in Australia. So his work included in my presentation, and also Professor Priyan Mendis. He's the leader of the director of the advanced manufacturing of prefabricated buildings. So all the studies have been done under his supervision and his leadership. So I have to mention that before I'm going to do the presentation. And also I would like to, first of all, I would like to acknowledge especially Nobel laureate and former US Vice President Al Gore. Because of him, actually, I'm presenting today, because I have been trained in his the climate related training. I had a chance to meet him and even participate this training program personally there. So he's the main reason behind this presentation, and also the reason why I really got into climate change and explore that the area. And also he allowed us to use his presentation slide to promote climate actions. So I would say more than 90% of the slide is from President Al Gore. So I think I would like to acknowledge him first of all, and also Professor Ranjit Senaratne, Ranjit Shanaka, for the chairman of Green Building Council, as well as is this secretary to the State Ministry for Rural Road Development. So I would like to thank him for giving opportunity, and also Mr. Lionel and also Ms. Situmini for arranging this talk. So this is a summary. Basically, I'm going to cover two things today. First, the climate change, because without knowing that, without knowing the impact, without knowing the risk and its vulnerabilities, I think there's no meaning of think about how we can work against that. So I think because of that, I thought first I should go a little bit depth into the climate change. Actually, we have heard that word, but I don't think we really understand the impact, the danger of that, because I believe that's the huge threat. It's a huge threat to the mankind, and also it's irreversible. We have to act at least 2 decades beforehand, because unless we may not able to reverse it, or it will take more than 2 or 3 decades to take our climate into the equilibrium. Okay, but then we may not have time. So then I would like to talk about what we can do as a professionals in the construction and building industry. So that's what I'm going to cover today. My only worry is timing, so I may be little bit over the timing. I hope all the audience, the participant will remain, because I didn't want to remove some important things, because then I may not get another chance to present this content. So I'd like to move into presentation with that. So this is a very important picture in our human history, because this is the one and only the picture that we can see the earth as a whole. This photo was taken in 1972 from last Apollo mission, when they were going to the moon. So this picture called Blue Marble, actually this is special picture because this is the earth. This is our habitat and our home. So we have to understand this is our sanctuary. And also this picture actually changed how the people, the environmental people think about the earth. So I think when it comes to the climate crisis, there are three major questions: whether we change, can we change, or will we change? The first question is, must we change? Actually, the nature is asking us to change. So that's the observation that we are seeing from the nature. So we see the changes in the environment, and the nature actually asks us to change. So this is what I'm going to show you in the next couple of slides. So this is like the sunrise on Earth. You can see the tiny the layer there. That's our atmosphere. Actually, our atmosphere is very thin than what we think. The diameter of Earth is around like 5,000 to 6,000 kilometers, but the thickness of the atmosphere is like around 50-60 kilometers. But the thing is, every day, like we are emitting around like 152 million tons of the greenhouse gases. So if you add it, like it will be around 1.8 gigatons of greenhouse gases. So unfortunately, the atmosphere cannot take it. The reason behind that, we know this there's the energy equilibrium in our atmosphere. Like usually in a day, like we get 340 of like irradiance from the sun, but again like around like that 340 should return to the space so that we will have a equilibrium in the atmosphere. But what happened, and also there's like a 342 of like irradiance actually circulating in our atmosphere. That's what keep us warm when there's no sun. So what happening, because of the greenhouse gases, this portion, like the whatever the energy like circulating in the earth, like increasing day by day. So if you look at the carbon dioxide emission in our history, like let's say last 800,000 years ago, right? So this is the pattern. We can see the minimum and maximum levels based on the ice ages. So if you see if you plot the temperature below that, you can see there's like a closely correlation between the carbon dioxide the content and the temperature. So then if you see the emission in 2019, you can see a distinctive like a big difference relative to the last 800,000 years ago. So we can clearly see that the man-made activities, or the activities caused by the human caused this increase. So then after 40 more years, we can see if you like if you're going to emit like that after 40 years, like this will be the carbon dioxide level. So you can see the difference. So it's a huge difference. So if you're going to emit like that, there will be a huge carbon dioxide concentration in the atmosphere that lead to like the global warming. So and also if you look at the carbon dioxide released in the atmosphere in the currently it's like it's the highest relative to the last 666 million years ago, right? So then if you look at the carbon dioxide emission since the industry revolution, we can see there's a abrupt change there. So there's a sudden increase in the carbon dioxide emission. So due to the fossil fuel. So this is the main reason behind the global warming. And also if you look at the greenhouse gas emission by gas, we can clearly see the carbon dioxide is the main component. So there are several gases, actually methane, nitrous oxide, but we have to accept the carbon dioxide is the major reason behind the global warming and the climate change. Right. So the truth is that, as I mentioned before, so at the moment, the greenhouse gas emission or the greenhouse gas, the level is unprecedented, and it's the highest related to the last 800 years. So someone can think like the carbon the greenhouse gases may not be the reason for this climate change, because there are some anti-climate change, like the people, they think like there are some other reason for the climate change as well. So actually there are some other reason that can cause the global the increase of the global temperature. Some reasons like the volcanism, aerosols, and sun energy output variation in the Earth's orbit. But the climate scientists, they have found that actually they are not the reason, but the carbon dioxide emission and the other global greenhouse gas emission is the reason behind the global warming. So we have to accept that the human influence is the main reason behind the global warming and the climate change. This has been well proved by the climate scientists, and it's available in the UN report. So if anyone thinks like it may be a natural cause, actually it's not a natural cause, actually it's due to the human. Right. So then I would like to discuss like what are the observations that we can see in the atmosphere and in our surrounding. So this is the temperature, the global surface temperature over 140 years, like since the the revolution. So we can clearly see the increase of like the temperature. If you look at the current temperature now, the temperature increase about like the 1 Celsius degrees. And also this is something I found for Sri Lanka. So the weather data, actually there are some few research on the climate change and what are the observations for Sri Lanka. So according to the HTRHP like the research, we can clearly see that there's a 0.9 Celsius increase in Sri Lanka from 1900 to 2014. So in Sri Lanka also we are experiencing the global warming. It's around like a 1 Celsius degrees. And also some research say especially in Nuareli area, like in the night times, the temperature has increased by 1.8 degrees. And also in coastal area, there's a variability in the temperature as well. Some areas like they observe like 1.6 Celsius increase, but in Baduge area, they observe like a reduction in temperature due to the change in the wind patterns. So Sri Lanka is experiencing the climate change. We can clearly see the warming in Sri Lanka, and also this is the temperature, the temperature graph. This is a famous normal distribution in 1950 to 1980. So this white area is the average, the red area is the warmer time, and the green is blue is the cool days. So what happened with the time? What is happening? The scientists have observed this temperature curve is moving forward. So it's moving forward so that we are experiencing some more hot days than previous. So this is what's happened between 1994 and 2004. You can see clearly a shift of 1 Celsius degrees, and also you can see the right side. This is right side. This is the extreme temperatures. So now what's happening, like because the curve is like shifting. Now we are experiencing extreme temperatures now, extreme hot days. So we are continuously moving in that direction. So what will happen, even though like the temperature is like changed by 1 Celsius degrees, but if you think about like the hottest days, the temperature difference can be even 3, 4 or 5 Celsius degrees. I think we have experienced that in last in Sri Lanka also. We experienced, I think, 36, 37 Celsius, or even I heard like even some areas is like 38 Celsius degrees. So if this continues, like even we may experience like a 40 or something more than in the future. Right. Then, so so the hottest, like 19 of the 20 hottest years, like basically happened in last 20 years, and the last 5 the years has been the hottest in the human history. So this is like a special thing, because like why it's happening now, why it hasn't happened before, because 19 out of 20 like hot years, like the last 19 years, then the hottest 5 years like the last 5 years. So this is showing the correlation between the global warming and the present emissions. So, and also if you look at like if you look at the temperature records in the world for 2018, actually 224 locations around the world, actually they recorded highest temperatures in their history. And also last year, like Professor Chandana Jayaratna gave a statement to Daily Mirror, like saying Sri Lanka is experiencing its highest temperature level in 140 years. Like, so actually, I don't know whether we are observe that, but the climate change, the global warming is happening, even sometimes without knowing. So it's happening, but we don't notice, because if there's like a disaster, like a flood, we see these things, like the consequences from our eyes. If there's a tsunami, we see the consequences. If there's a storm, we see the consequences. But the climate change is like a silent killer. So because we can't see the direct impacts, but it's happening underneath. So not only Sri Lanka, in Pakistan, they recorded the highest temperature in their history, 54 Celsius degrees. In Japan also, they experienced the hottest day of their history, 39.5. Then 125 people died. Then around 57,000 people taken hospital. In also South Korea, they experienced the hottest day in 2018. And Europe, of course, like many countries in Europe experienced the hottest their hottest day in their history in 2019. In France experienced like 46 degrees. That's the highest that they observed in their history. Not only France, also in UK, Austria, Belgium, Poland, and Germany, they experienced the hottest June on their record. So in Australia, if I like the Australia, like Australia also like experienced the hottest the year in the history. Like you can see, this is the temperature increase in Australia. You can clearly see how the temperature is increasing. So then in 2018-19, Australia, many states like recorded the highest temperature. And also there's a correlation between the temperature and the fires. You can see the temperature and the frequency or the intensity of fires, right? So in Australia, what happened, Australia recorded its highest temperature in 2019. And also you can remember there was a big the fire, the bushfire in Australia. So this is, you can see this the smoke. This is like 40-50 stories tall. And also this is what happened to city was like covered by the smoke. The air quality was very poor. Even we felt like the smell of the smoke. It wasn't breathable, to be honest. Like even the people with asthma, they couldn't breathe and they got a lot of problems. And also this is the area like burned in 2019-20 bushfire. It's the highest relative to their previous record, and it's about like 7 million hectares. It's actually bigger than the size of Sri Lanka. So you can imagine the size, the consequence of that bushfire. So the hottest year was 2019. Then Australia experienced their biggest, like, the bushfire in the history. So this is the like a very tragic picture from from bushfire. Actually 1/3 of koala population died in New South Wales. It is found that around, like, it's estimated that around 1 billion animal actually perished, and also some species, like, they're extinct. So right. Then actually the NASA, like, they say the accelerated fires, they observe an accelerated fire cycle in the recent history, and they are getting more frequent and severe than before. So that's one observation from NASA. So then what is the observation that we in the cryosphere? Cryosphere mean our ice layers. So our ocean, this is the ocean heat content in different layers of ocean. So we can clearly see how the heat content means the amount of heat absorbed by the ocean. The ocean is like a capacitor. So we know what's meant by the capacitor. Capacitor is the one basically store the electricity, like and they discharge. So, like, when it comes to climate change, the capacitor is the sea. Because it's water, it has a higher the heat capacity, so it can absorb a lot of heat. So we can clearly see the ocean is actually taking the burden, because the soil or the land cannot absorb the heat that much as the ocean. So the ocean is like absorbing a lot of heat. So what is happening in Arctic region? So this is what's happened in 2018. You can see the snow is melting. This is the real North Pole. You can see how the snow is melt, right? So in this was February. February is like just after the winter. So 28 Celsius degrees in North Pole. So that's not something usual. And also the North Pole has experienced like mid-winter heat wave 3 years in 2016 to 2018. And also this is the ice loss in the Arctic region. So you can see in recent decades or recent couple of decades, the ice content of the Arctic has lost significantly. So now you may like so I mentioned like there's a 1 Celsius degree increase in the surface. So does it really matter? Like when we say like 1 Celsius degree, like it's come to our mind as a 1 Celsius degree we can tolerate, actually, isn't it? So like say whether it's 28, 29 or 30, it doesn't matter. It's like we can tolerate. But the thing is actually that Celsius degree matter, because 0 Celsius degree at 0 Celsius degrees the water is ice, but at 1 Celsius degrees it's water. So this 1 Celsius degrees actually has a big impact on the environment, because the ice can melt. And also not only that, many species very sensitive to the temperature. So what is happening? So this is like this picture is like from 1920-30, but this is now this is the situation in 2015. So you can see the clear difference between what has happened in last 80 years. Like this mountain was covered by the ice. Actually, this is a glacier. You can see this glacier has vanished. So you can see the difference in the Alaska, for example. And also this is another glacier in Greenland. This is what has happened today. So there's a big difference. The decline of ice mass in Greenland is severely like decreasing, and this water is going to the ocean and changing even the patterns, like the flow patterns in the ocean as well. and it changed the climate as well, because for example like El Nino, La Nino, the climatic, like the climatic things, right, that really relate with the ocean. So if we change the heat content of the ocean, what will happen, it can directly related to it can influence the climate system as well. So then, as I mentioned, the snow is melting. This is the sea level rise. Like last 100 years, like in average, like we are observing like a 200 millimeter sea level rise. But again, this is average. But in like a wavy day, this can be like even half a meter, or even it can be like 1 meter, because this is average. Like because if you consider the let's say right hand side, which is the extreme ends, this may be much higher in some areas, like even the sea level rise is like more than 200 millimeters. So in Sri Lanka, again, like I try to find some data for Sri Lanka. What I found, like I found some research like on sea level rise in Sri Lanka. So between 1901 to 1961, there's like a 120 millimeter sea rise, millimeter sea level rise. Then what I found, like from 1994 to like 2020, within like 18 years, like there's like like around 50 millimeter sea level rise. But again, we have to keep it in mind, this is the average. So in total, there's like a 200 millimeter sea level rise that's really matched with the global average. But again, in a high tidal day, or like in a wavy day, like that can be like a half a meter, even beyond that. So that can erode the coastal lines. So then some research found that the sea level rise is like 2 millimeters per year, which is marginally higher than the global average. And also this is like some research from the Disaster Management Center Sri Lanka and Sri Lanka and UNDP. So they did like collaborative study. Then they found that this is the area of lands affected by climate change in different districts. So according to that report, Puttalam, Hambantota and Jaffna Goal, they are vulnerable for sea level rise. The reason, because there are a lot of like low level lands. Then this is also like taken from that the report. This yellow area is like the affected area due to the sea level rise. Actually, what will happen? There will be like the sea water will actually intrude into into the land, and it will mix with the fresh water. That can really affect the cultivation and the paddies in the coastal areas. And also that can affect the drinking water as well, because our most of like the water supply systems or the purification the facilities are located in the coastal regions. So that can really affect our the drinking water as well. We know even sometimes the Kallan River has that problem. I think Ambatale, I think sometimes it get affected. So same thing happened in Nilvala River as well, in Matar area. So and also studies found that 30% of Earth population country experience potentially deadly heat 20 plus days per year. So then at the end of century, this will like 6 days per day on average. Actually, what will happen, because the increase of temperature causes like the unlivable conditions, and also in some areas like will be inarable. There will be like a food shortage, and there will be like a social problem. What will happen, like people start to move into cities, like especially the cities. That's something found in the studies, like because when the farm field are not arable, the people like gave up the cultivation and they move to the cities and looking for the other jobs. So the one report like predicted that there can be 1 billion climate migrants, especially North African region, because they are very dry areas. So they are the people who are suffering from climate change more than the us. Even so, it is believed there will be a lot of climate migrants. So that can be a huge problem in the future. So, so U.S. Department of Defense actually, according to their report, they say the climate change is not only about the global warming, but it will affect our food, water, and also cause pandemic disease, because when the temperature increasing, there's a window for the viruses and the bacteria to spread, and also dispute over refugees and a lot of destructions and disasters in the nature. So then I discuss about the some observation. So what are the risk and vulnerabilities that we have? So so this is I hope you can see, this is the moisture, the graph or the cloud of the earth. You can clearly see when the moment there's a storm, like a cyclone forming in the Bay of Bengal. So this cloud are formed actually through the evaporation. So the cloud and the moisture is very sensitive to the surface temperature or the temperature in the sea. So the warm air can hold a lot of more water vapor. So what will happen when the temperature rises? What will happen? There will be a lot of evaporation, and at the same time, when the air in the atmosphere is warm, it can hold more water. So what will happen? Every 1 Celsius degrees, what will happen? The water vapor will be increased by 7%. So it's a huge amount actually. So it is 1 centimeter, 1 Celsius degrees, but the it can hold water vapors more water vapors. So right. So then so now what the scientists have observed, they are observing 5% more water vapor over the ocean before the 30 years ago. It means we will get more rain day by day. And also this is one satellite picture taken over USA. So this is the Hawaii. So this is the California. So you can see the moisture. So actually there are rivers actually. They are rivers. They are called atmospheric rivers. So what will happen when there's a lot of moisture in the atmosphere? They will form this kind of the rivers. So what will happen then? This will flow towards the lands, and it will generate a heavy shower. So this is the atmospheric river. Next day there was a huge flood in California. So what will happen? The global warming will increase the water vapor in the atmosphere because and also it can carry more water in the clouds. What will happen? The intensity of the cyclone will be increased. Then the precipitation or the weather events happen in the history between 1980 and 2050. We can clearly see there's a increase in the extreme weather catastrophes, the increase of the floods, increase of the mudslides, increase of the storms, increase of the extreme temperature. So this is going to increase continuously, if you are not going to act. So actually this is a very important graph, because this clearly show what is the trend with the increase of the temperature. So as I mentioned, this is the change in the precipitation over the globe. So there will be like a change in the precipitation. In some area, we will receive like higher rainfall. In some areas, like the rainfall will be less. So so what will happen, as we know, like our irrigation and our the cultivation, they are based on the precipitation or the patterns. So for example, in the Yala season and Maha season, like we plan our crops, we decide what to plant or the sow. So but the thing is, what will happen, this pattern is changing, and the same time there's a change in the precipitation. So it's very difficult to like manage the crops, like, and also manage the irrigation, because our dam systems, our irrigation system designed for those patterns. But when pattern is changing, our reservoirs are not designed to store this much of rain, for example. So there will be a lot of consequences for our cultivation and our paddies. So this is something I found in for Sri Lanka. So if I give the summary, actually there's a in total there's no change in our rainfall, but there are changes in the seasons. For example, in Yala season we are getting less rain, but in Maha season we are getting a high amount of rain. So there's a change in the rainfall. So what will happen? The farmers who are farming from Yala season, their crops should be experience some problem. Their yield should be less. But the farmers who are farming using Maha season, they may experience more water. But the thing is, the question is like how that excess water is coping with the crop types. So there can be a problem. So right, we'll skip this one. So, and also the research found actually there's a shift in our agro-economical boundaries. So that's very serious thing, because ecological boundary is very important thing, because agro boundary decide like our crops, the timing and everything. So if the boundary is shifting, means actually the paddies or the areas which in that close to that the boundary really affected by the climate change. So this will actually affect our agriculture. So and also there are a lot of observations on rare precipitation. It means like rare weather incident. For example, like in Argentina, 1 year of like rain, like falling like one day, and there was like a huge flood there. Similarly, in Texas, 1.54 meters of rain happened in like in a one day. So there are extreme events like that. And also this is the precipitation, like record-breaking precipitation in the world. You can clearly see actually nature, the nature is breaking its own records. So that's why I mentioned like must we change. So the nature is like alarming us. So nature is like breaking its own records, like in precipitation, in floods, in fire, in storms, in ocean, in Antarctica. It's breaking its own record. So it saying to human, please change. So that's a message from the earth, from the nature. So the global floods and extreme rainfall even now occur 4 times more often than 1980. So this is the message from the nature. Right. So then this is some observations and some the impacts on the ocean and the species. So we can this is the temperature change in the sea surface. So what's happening? There's a huge coral bleaching around the world. We know what has happened to Hikkaduwa. We can't see any corals there, right? So so what has happened now, 50% of Great Barrier Reef is like a World Heritage. So now it has bleached. It will take like 100,000 or 1,000 years to grow, getting into the normal condition. The thing is like within in last 30 years, the coral breach, the amount of coral bleaching is like a 50%, but 30% happened in since 2016. So that shows like the impact of the temperature rise. And also this is also like a very interesting thing. Some species like really sensitive to the temperature. For example, this sea turtle, like they are very sensitive to the temperature. Actually, because of the temperature change, 99 of like them are like females. Actually, the marine scientists here, like they genetically now they change the genes, and now they are reproducing the male turtle so that they can have babies. So you can see like a small change in species. And also I mentioned not only the human, it is found that the animal also like moving 4.5 meters per day towards the poles, like the north and south, because the temperature is rising. So their habitat, they can't live in they are the original the places, though they are moving 4.5 meters per day towards the poles. Right. So then so this is the conclusion of the climate change. So these are the impacts. It's huge. It's caused political sea level rise, climate refugees, famine, then the impact on the ecosystem, the water, so our agriculture. So there's many threats due to climate change. Right. So now the question is, must we change? Yes, I think we have to change. There's no doubt about that. So then we have like basically the world got together and like try to find the solution for that. The Rio de Janeiro, the Earth Summit is the first step. Then the Kyoto Protocol came. Then the new one is the Paris Agreement. So the key message of the Paris Agreement is to reduce the global warming, reduce the global warming and keep it like at 1.5 Celsius, because the climate scientists say that is the tolerable amount that for the human and for the nature. So there's a global warming, like we can't reverse it to the zero. At the moment it's like 1 Celsius degrees. So now what we are trying to do is like stop that at 1.5 Celsius degrees. So that's the target. So this is like a very important graph. So if you can look at that, so the red line is the current trajectory. Like if you go like this, like if you don't do anything, what will happen? We will end up with like a 4 Celsius degree different. So again, it's an average, but in like a hot day, or the maximum can be even 8-10 Celsius degrees. So we are talking about like maybe like more than 40. So we may experience like a more than 40 for like a 40-50 days, something like that. So this is the average. So but what we need is the blue line to keep it at like 1.5 Celsius degrees global warming. So I think this is very important, like a graph, because this show us like where we should go. So this is the temperature. X-axis is the temperature. The y-axis is the total carbon dioxide in the atmosphere. So to keep 1.5 Celsius degrees, this is the carbon dioxide can be in the atmosphere. So it should be like somewhere around like 2,600, 600 gigatons. So this is what can be basically exist in the atmosphere in order to keep the global warming at 1.5. So this is very important. So the thing is, the carbon dioxide is fixed. So the amount can be exist in the atmosphere is fixed. It's to 2,600 gigatons. So this graph basically explain to stop at 2,600 gigaton, what is the emission? So this blue line, the dark blue line, is the path to stop the carbon dioxide amount at 2,600. So can you see it is going down and come to the zero? So this is I think very challenging thing, because our emission has to be zero in the future. So according to this graph, it's maybe like 2060 or something. But the thing is, because we are not going in this path, we are going in like an upper path, but then suddenly we have to come down. So we have to achieve net zero somewhere around like 240 or 50. So it's a very difficult target, because like to stop the climate change, or to limit the global warming at 1.5 Celsius degrees, we have to be net zero. Our emission, the emission from human, should be zero by 2040 to 2050. That's a huge challenge. Like, can you imagine, like, can we be like net zero within like another 20 years? That's a big challenge. So that's the only way to stop the global warming and the climate change. So so this is like a quick summary on like who are the emitters. Like the biggest the emitter is China, United States, European Union, and India. So actually they have a lot of responsibility in the climate change, because if you see the other countries, like they are only 30%, but let's say six countries actually committed like or they contribute like 70% of the emission. So, but if you look at their commitment to reduce the emission, it's very low. So that's why the climate change is so challenging. So can we change? Yes, I think we can change. This is the reason for the emissions. The fossil fuels, you can see there's a huge increase in the gas, oil, and the coal. So they are the main polluters. And this is the emission, the carbon dioxide emission to produce 1 kilowatt hour, 1 kilowatt of like energy. So we can see coal and oil and natural gas are the leaders in emission, but the renewable energy is much less. So basically the skip this one. So basically the solution is go to the renewable. So that's the solution. The thing is, even though there is a lot of coal, we can't burn it because of the climate change. There's a lot of coal actually. There are like coals more than we burned before, but unfortunately we can't burn them because of the climate change. So we have a solution in hand. So the wind and solar is the solution. The wind can basically generate the 40 times the energy that we need, and the basically 1 hour of solar coming to Earth is enough to like supply the energy need for a full year in the Earth. So, and also the cost of like the wind and solar is like decreasing, and at the moment, like in Australia, the solar and also like that, because recently I observed, like I found that even the cost of the Tamba Pavani the plant, the cost for like 1 megawatt is cheaper than the Norachole power plant. So I think it's same for Sri Lanka. Even the PV, I think the cost for 1 megawatt should be like approximately equal to the normal the methods. So and also this is the opportunity in the climate change. So this is the prediction. This is a prediction how the let's say demand for the energy considering the climate policy. So in order to like achieve the climate policy, so to avoid the climate change, solar and wind has to be increased exponentially. So that's the one option. You can say coal, it has to be remain constant. Actually coal will not have a future in future, and also many banks, they do not basically invest, or they don't give loans on to invest in coal, because they know it's not going to work in next couple of years or in next decade. So they are more
Dr.
working on.
Shanaka,
Yeah.
yeah, there's an issue with the slides. We can only see the cost of carbon slide still.
Is that?
Yeah,
Oh, sorry. Cost of which
carbon.
one?
The cost of carbon slide.
Cost of carbon slide. This one? No.
Yeah,
Oh my. I think I have cost of sorry.
uh,
Which slide?
You
it's
can share it as a new shares.
yeah.
Is that? Oh, okay, I think that's a good idea. I will do like that. Cost of carbon, my God. So I think this one, right? Sorry for that. I think it got stuck, no?
Yeah, sir.
Right. Now can you see?
No.
I think I
So we missed.
can you see now?
Yeah, we can
Yes,
see the
now
slide.
we can see some graph. Yes.
Yeah. Okay. I think I explained these ones. Sorry, like right. Basically, I think I show here, like, so basically to avoid the climate change, this the blue line. The blue line is the trajectory for the emissions. It has to be like a net zero. So we can't actually our the emission should be zero by 2040-50, because like we are not on this trajectory. So actually now at the moment, like, we are on the red trajectory. So to achieve that, we have to have like a steep like a reduction, and we have to achieve like the net zero somewhere around 2040 and 2050. That's why many countries like targeting net zero by 2040 and 50. Victoria also same. I've seen even in Sri Lanka, like targeting to achieve net zero emission by 2050 or 40, somewhere around there. So this is must. So this is a huge challenge, as I mentioned previously, because like can you imagine like not emitting carbon dioxide? So we are emitting like let's say 50 gigatons, around like 1.8 gigatons per year. So how can we do that? That's really challenging. So these are the emitters, like these countries, China, United States, and India, like they have to play a big role in the climate change, but their contribution is very less. That's the challenge that we have. Right. Can we change? Of course we can change. The main reason behind this carbon dioxide is gas, oil, and the coal. So and the thing is, like, to produce like 1 kilowatt, actually the fossil fuel, they emit a lot of carbon dioxide. For example, to produce 1 kilowatt of kilowatt from coal, it produce like around like 1 kilo, actually this is in grams, 1 kilo of like carbon dioxide. So then I will skip this one. So the solution is basically transition from fossil fuel to renewable energy, because it has like a very less emissions. We have the solution in hand. So the solution is like basically the wind and solar. We know that the wind has the capacity to generate 40 times the what we need. The 1 hour of solar is enough to like supply the energy for like 1 year. And also the cost of like the wind and the PV like decreasing dramatically, especially like in the cost of the Tambapawani Tambapawani, the wind power plant. I can like what is the cost for like 1 megawatt? Actually, they are like almost a plant in Rocholi. So it means like the cost of wind is like, I know the government has a plan to develop like a solar power plant in Hambantota area. So this is the energy demand in the future according to the climate change policies. So there's a huge opportunity for solar and the wind and also hydro, but it's limited. So you can see the coal has to be remained constant, but we expect the gas will be increasing because the liquid natural gas has a less emission than coal. That's why in Sri Lanka, like we are going to transform our oil power plants to the natural the gases. So there's a huge opportunity basically in solar. So this is a quick summary on like what's happening in those countries, like who are the major emitters. So in China, the new capacity, 53% of new capacity is solar and wind. And Europe, you can see it's mainly solar and wind. 88 is like solar and wind. Then if you look at US also, like you can see around like 50% is like solar and wind, but they are using natural gas, and also they are shutting down their coal power plants. Even though they withdrew from the Paris Agreement, but we expect that with the new president will again enroll to the Paris, or they will comply with the Paris Agreement. So renewable energy trend in Sri Lanka, as I mentioned, climate change is a problem, but again it's an opportunity. So the government is like planning to supply the country's energy, 70% of country's energy demand from renewable energy. So we recently saw the opening of the Tambapawani wind farm, and also so Sri Lanka has basically declared the plan for the climate change. So they have pledged to reduce 20% emission in the power sector, 10% reduction in the other sectors, including the building, the industry. Then the eliminating or introducing of new coal power plants. So there won't be any coal power plant in Sri Lanka after we achieve the 4.7 gigawatt capacity. So there's only one space for a coal power plant, which is 250 gigawatts according to the CB planning. And we have pledged to like add 514 megawatts of wind farms and 115 megawatts of solar farms. So that's what's happening in Sri Lanka. Now we can clearly see how the sustainability or the environmental factor is like shaping our energy policies and the politics and many things. So now we can see the impact of the nature's call. So we have to follow that. We have to change, because the call or the response from the nature is much stronger, much strong, so that even we can't put like a coal power plant in our country, even though like we are not an industrialized country, we can't put a coal power plant. So that is the strength of nature, and that's the call from the nature. So, but unfortunately, this purple line is where we should go, but this is the green line is where we are heading. Like still there's a 40.7% of shortfall. So this is where the world is heading, but this is where it should go. But still there's a big difference between our expectation and the reality. So that's a huge challenge for the climate change. So this means like actually after 12 years, it's been 2032, we will reach 1.5 Celsius degrees. So again, like we are late. So to reverse it back, again, it will take another probably 15 years to change that back to 1.5. So so the thing is like time is like 2037. I think, can I continue, Situmin? Is that all right?
Yeah, so you can continue.
So I will go through quickly what we can do, especially the construction sector. So because the building industry, as I mentioned, is responsible for the 39, around like 40% of the emission. 28% is the operation energy. The other 11 is the processing. We call this embodied energy because it's hidden. It's before it's the what we call the cradle to the site basically. So that's an embodied portion. Actually, it's a hidden part we don't see. We see the operational energy because we see our light bills, for example. So the operational is like 28%, embodied energy is 11%. So if we want to act, if the building sector wants to act, we have to reduce the both operational energy and the embodied energy. So this is the outline. What we can do basically, we need a life cycle analysis. We have to lower the operational and embodied energy. I will explain how we can do that. And we have to design for reuse, recycle, and the decompose. And also we have to increase the efficiency and productivity in the construction. For example, prefabrication, I will explain, and also design for Green Star. So our Green Star system actually very efficient framework to tackle the climate change. I will explain that shortly. So if, like I said, like we want to decrease the emission. So if you want to decrease the emission, then we have to capture the full the spectrum of emission. So from birth to the death. So that's why I need life cycle analysis. So we analyze it's the full life cycle, even not only it's up to death, but also how we can regenerate from that, how we can reuse that. So or giving a new birth to that end. So this is the life cycle, the analysis, like from extraction of material to the disposal or to the end. That's called cradle to grave analysis. So cradle means the birth, the grave means the end. But the new concept is the cradle to cradle analysis. Like you try to make a new birth out of that. So we will use reuse, we will remanufacture, we'll recycle the component, and we will use it input in different stages. So this is the full analysis we have to do in order to calculate, in order to estimate what is the emissions. So this is the framework that we are using. There are several frameworks. So this is the European Union, the EN standards 15978. It has a framework for life cycle analysis. It has like 4 stages: the product, assembly and construction, the use, it's the operation stage, and the end of life. So this is the framework that we use. So to calculate the or estimate what is the total emission or total energy of the building. Then I mentioned like the reducing the operational energy. So I think in Australia there's a energy star rating system. I think that's very strong, like a framework. It's mandatory, like for the residential building. So we have to achieve 6 star in order to get the permit from the council. So the framework is the NATHERS. The software is the Accurate that we use here. So that has the basically this energy star rating system is focusing on the operational energy, heating and cooling only. Then the software basically has the material databases and also the climate, the files, including the temperatures of different climate zones. So we can simulate and we can find what is the energy we need for unit area for 1 year. So you can see, for example, 68 megajoules per square meter. So accordingly, they give the rating. So the thing is, when we like even going to sell a house, if we have a higher energy star rating, that also like one feature like we consider. So this is the energy rating system. They define like what is the energy for the different stars. You can see different like the places has different the values because the temperature or the climate conditions are different there. So I think it's good like if we have something like that for Sri Lanka as well, like defining like basically what is the energy, the allowable energy limits and the star rating levels with considering the climate condition. For example, for Nuwara the energy requirements may be different to the, let's say, Colombo. So I think this rating system is so powerful, so it's limiting the operational energy. And also we have the access to these climate zones and the temperatures. That's something we need for the simulation, because the climate data is so important for the simulation, because the exterior, the temperature, the solar, the wind, and those factors are quite important to evaluate the operational energy of a building. Right, then the simulation, I think we use the accurate the software, but EQS Energy Plus software also can be used for the simulation if you have the climate, the files and the weather data. Then the as I mentioned, in the future, like we have to be like net zero. It's inevitable, like in the future, like it has to be net zero. Our buildings, our many operation has to be net zero. So the how to achieve the net zero, it's very in a simple term. First, like we have to reduce the emission. First, we have to do a life cycle analysis from birth to cradle, or the cradle to cradle. Then we have to like find how to reduce the emissions. Then always there will it will be a positive number, because we can't because material consume energy. So at the end it will be positive. Then we have to offset that using the renewable energy, or like some other means like a forestation or carbon like a credit system. So that's the simple, like that's the way of achieving the net zero. So right, so as I mentioned, like for the net zero building, we have to basically capture everything in order to achieve the net zero. So then how to offset? So there are two ways to offset. Either we can invest for the like the renewable, or like the, let's say, the forestation, like the like something that we can claim carbons, or we can buy it. Like this is I think a good idea we can implement for even the Green Building Council. I think Professor Ranjit also in the audience. I think if we can create a green let's say carbon bank in the Green Building Council, so that the people who want to develop zero energy buildings, they can basically purchase from the Green Building Council. For example, the people who are going to invest on renewable energy, they can basically deposit that in your green building account, for example. So they get the money from the carbon crediting, as well as the by selling their renewable energy to the CEB or LECO. So I think that can be like a good marketing model for net zero building. Yeah, then these are a few ways you can like offset the emissions, like revegetation, wind farming, solar PV. At the moment, like the Australia has like a carbon crediting system. Like we can basically prove we save this much of emission, then we can basically convert that into money. So 1 ton of like carbon dioxide, I think it's 1 ton. Yes, I think it's equal to $21 or something. So we can buy it, or we can deposit it. So government also has like a brand scheme to basically to generate the carbon credits. Right. So then net zero initiative. So I think there are some net zero initiative from World Green Building Council. There are some Green Building Council around world has initiated some net zero buildings, and also they have given guidelines. So I think it's good to go through these guidelines and find like they have different like approaches, but I think good to study them. And also this REBA one also like has some guideline, Royal Institute of British Architects. So they even specified like what are the emissions by 2030. 2030 is like important year, because that's according to the Paris Agreement. According to the Paris Agreement, we have some guidelines to achieve in by 2030. So REBA, Australian Institute of Architects, they say after 2013, every building has to be net zero. So I think there will be a big demand for net zero buildings, and also carbon crediting, because we never ever able to like make a net zero building. because we are using material, we can reduce it, but we can't achieve net zero without offsetting or carbon taxing. So this is like a net zero energy and zero emission housing in Japan. So I visited Japan like a couple of years ago. They are very good in that actually. So it's like a common thing in Japan. So this actually the roof tiles are actually PV tiles. So that's how they achieve the net zero. They look very natural. They don't like actually net zero house. They are very architecturally very sound. And also these are on the other side of the roof. So one side is like a PV tiles, the other side they have vegetated, because they can use that the carbon sequestration from the plants for their net zero calculation. So revegetation is also like one way you can achieve. So this is how you can reduce the energy consumption using the PV. Some up to 90% can be like reduced using 5 kilowatt like a PV system with like a like the battery. So that's something they showed in there. So and also some smart energy management system. That's also like one method. This is something I observed in University of Tokyo. So that this is like a prototype for like a smart energy management system. So they have like the solar heaters and the PV system with the storage and the double facade, and the windows like connected to motors. So they have like a controlling system, very smart controlling system using the artificial intelligence. So they control everything. So they decide whether to switch on the air conditioner or whether to open the windows by looking at the wind speed and the temperature outside and inside. And also they decide like whether it use the PV, the energy from the solar panel, or whether they are going to get it from the grid. For example, because in some time, in some duration of the day, it's worth to get power from the grid, because it doesn't use the let's say the fuel, the fossil fuel, for example. So likewise, it decides the what energy source and how to control the windows. So very smart system. So I think, and also they connected that to the Google, like the Google system, smart home system, Alexa. So even you can control many things using that. So then how to increase the productivity of construction sector. So this graph shows like construction sector is not very productive. You can see all the roofing, painting workers are there, but automobile and the other industries like very productive. So, and the labor, I will skip this one. So this is the productivity of like the different construction method. We can clearly see the modular homes, complete factory built home, the precast, they are here. Their labor productivity is so high. At the capital, even the capital investment is also high, but the labor productivity, the productivity is much higher. So one way of like increasing the productivity of the building industry is the prefabrication. Then actually we are working in this the advanced the ORC Research Center for Advanced Manufacturing of Prefabricated Housing. Professor Priyanmen is the director. Actually, that's his basically initiation. So we are working with many industry partners at the moment. Then this is a potential. The life cycle cost can be reduced to 50%. If you design for reuse and recycle, like you can use 100% of component after the end of use. 80% of site wastage is recycled, 50% reduction in greenhouse gas emission, and also 70% reduction in transport. It has a huge potential reducing the emission in construction industry. So this is like a one project that we are working. Timber building system is a timber system. It doesn't have any concrete. It has a steel, like a steel and timber hybrid system. This is the assembly line. You can see at the front the CNC machine is there. They cut all the section. Then in each section we fix the cladding to glasses and insulation. So we did like a full life like an environmental product declaration analysis. It's very similar to the green product the system in green SL system. So in that, like we captured like what is the different steps and processes material in the production. Then we capture like what is the energy use in different stages. So these like hot pot analysis. Now we know where the hot pots are. Then we compare what is the GHG emissions and the energy. So then we compare with the like a conventional concrete prefab wall. So what we found is like our prefab systems like emit much less carbon dioxide. It's like almost 50%. And also you can see the green GHG emissions. So the carbon dioxide, methane. So this kind of analysis can capture what is the contribution to the climate change. Then we did a like full life cycle analysis, considering not only the manufacturing, but construction use and end of use. So this is what we found. We can capture where we emit the carbon dioxide. So basically manufacturing process were the critical, but construction you can see it's less because we do a lot of manufacturing, we do a lot of fabrication inside the factory, less work on site. So because we are doing manufacturing on factory, it's highly efficient, and also the wastage is less, and also the labor efficiency is much higher. The quality is very good because the quality can be controlled very easily. So and also we did like environmental analysis. We can do the ecotoxicity to find what are the other chemicals, acidification. So that's also very important. Then the eco indicators, like how this product affect the human health, ecosystem quality and resources. Then we apply the system with this is a map of the Melbourne metropolitan area. So we apply this building into the new building in metropolitan area. So if we adapt like the prefab buildings, this is the energy reduction and emission reduction for Melbourne. So this kind of like analysis is really helpful for the council, because now the council or the cities, like they have to achieve this 2040 as net zero target. So this kind of analysis really help for the city planners and to take the decisions. So not only the operational, the embodied portion also important. We have to reduce that. So as I mentioned, 2050, the embodied portion has to be zero as well. If it's not zero, it has to be offset. So so I briefly explained, like as I mentioned, concrete like emit lot of the carbon dioxide. We know 1 cubic meter responsible 1 ton of carbon dioxide emission. So what we did, we used machine learning and we capture like the emissions. We use the machine learning, like we basically we predict the emissions. Then what we did, we basically predict the emissions of like of concrete for different strength, and we benchmark. So we said basically this is the range, like you can see this range, the interval there. So we basically saying, okay, you can't emit something beyond than that. So basically we benchmark it. So basically we create a benchmark for like a high strength concrete. So if someone is going to produce it, you have to produce within that range, because you can do that. So you can find that paper like if you like. So so in the future, we have to like, first we have to declare our emission. Second, we have to benchmark it. We have to say this is the limitation. You can't go beyond that. So California, I think the California City Council, they basically declared the concrete cannot emit, let's say, more than that limit. So they basically restrain the emission of the concrete. So the mixed design has to comply that. So in the future it will happen, like you will, like when you do something, you will get like a upper bound or like a, let's say, benchmark. This is what you can basically emit. So when we design something, we have to design below that level. So that will happen in the future. It's happening in USA, it's happening in Europe. One day it will happen to, we have to do that actually. So this is a mixed design, like we propose using the machine learning to achieve that, the emission goal. So we limit the emission, then we said like, okay, this is the mixed design, the cement or the fly ash, the slags, silica fumes amount that you can use in order to like limit the emission. So it's a quite interesting paper. So similarly, we knew that we have to reduce the embodied energy. So we came up with biocomposite system, which to reduce the embodied emission. So what we did, we developed this biocomposite system. This is actually hemp, cannabis. Actually, cannabis, the stem has a very lightweight like a material, and also it has medicinal use. So we are not using the potential of cannabis in Sri Lanka, to be honest. So we use that as insulation material. So it has a very good insulation property, and we combine it with the ultra high performance like a composite. So then what we basically substitute that using the brick veneer. Like this is the current construction method in Australia. There's a brick veneer, then the timber frame system. So we replace this brick veneer using that our biocomposite here. So then we did a life cycle analysis. What we found, this biocomposite system has a negative like embodied energy. How it's negative? Because the hemp, when we grow it, it basically absorbs the carbon dioxide. So it is negative. So this is a good sign, because if you want to like develop a net zero building, we have negative, like a negative carbon negative construction materials. So to achieve the carbon negative or neutrality, I think we have to combine with the biomaterial. But we know biomaterial is not fire resistive. It has some disadvantages, but if you make it composite, we can achieve the performances in the same time. So this is a very good example, basically to reduce the embodied energy and achieve the carbon neutrality. So using the biocomposite. So circular economy, I think I already covered that. Basically the whole idea of circular economy is like we have to design for recycle and reuse at the beginning. So I think we should like declare like what is the end use, or how we recycle, how we deposit the, like dispose the waste at the beginning. So I think that's also like a very good thing if we can do that. Like we declare, because after let's say 30-40 years, like when people want to remove the building, they know how to recycle it, what can be reused. So then this is like some architectural concept, like this is like a pod vending machine. Basically this is the building, the frame is there. What you do is like basically you rent a pod, you can move it anywhere, like you from city to city, you basically hang it there and connect to the services. So this is like one concept. So it's like a reusable house. The future building, like it has like a frame, that's it, only the frame. So you can basically click and connect a pod, then you get the power and the other services. So finally, this is I did a quick survey on how climate change and our green SL rating system coordinate. Actually, it's interesting to see like a green rating system is actually addressing the climate change very well. There are like around like 40 points directly related to climate change and the life cycle analysis. So if you do a life cycle analysis, if you plan for like a net zero, you can get some more than 40 points in the green rating system. We can clearly see green SL rating system directly like address the climate change. So if you go through the green SL rating system, you are knowing or unknowingly, you are basically try to avoid the climate change. So in conclusion, the construction industry has a big role in the climate change. The reducing operational and embodied energy is the key. We have to achieve net zero in next decades. We have to achieve that. That's a must. It's inevitable. Then circular economy has to be adapted. We have to declare, or we have to think about how we reuse, recycle at the end of use. Then renewable energy is the key to offset the emissions. And also the construction industry is so lagging relative to automotive and other agriculture. So we have to adapt new construction methods like prefabrication, and green star rating is directly addressing the climate change crisis. So I think with that, I think I took a lot of time. With that, I think I finished my talk. Thank you so much.
So thank you very
Thank
much,
you, sir.
sir, for that interesting and knowledgeable session. We hope you all received a good comprehensive on the new area of concerns from the talk. If you have any questions, you can direct them to Dr. Shanaka.
So, I think we do not have any time, no? So I think we can, I can answer like, please send me any, if you have any questions. Or I like to, it's like a 1 o'clock here, but still I like to stay and answer a couple of questions if you have any questions.
So there is a one request from a participant. He wished to have slide 90 again.
Yeah, 90 means like
Slide 90, sir.
90. Yes, this one. Give me a second. I have to share, no?
Yes, guys.
Yes, can you see that? Can you see
Yeah,
that?
yeah, sir. Yeah, we can see that. Yeah, sir, we can see that.
Yeah, I think I'm quite sure like we have a crowd with different expertise like energy, architect and quantity surveyors, engineers, and I think probably like developers, like the contractors. So I'm quite sure like there are a lot of people from different expertise. Like I think even they can contribute like from what they know. So I think it will be more like a discussion. I'm also like new to this area, so I'm also exploring, so more than happy to like listen to their experience as well. Yeah, so this is a 90. So is hello.
Yeah, sir, they wish to have explanation again. 90,
This
90.
one. So 90 actually the red line is where sorry, x-axis is the temperature, is the temperature, right? So the basically the global warming, the temperature rise. The y-axis is the year, right? So red one is where we are heading at the moment, right? 8.5 means the 8.5 teratons of carbon dioxide in the atmosphere, right? So this is where we are heading, right? But 2.6 is the 2.6 tera carbon dioxide in the atmosphere. So this is what we should have, right, in order to stop global warming at 1.5 Celsius degrees. So the nature says the carbon dioxide what I can hold, which safe to you is 2.6 teratons. So nature says, sorry, I can't hold more than that. I can't bear more than that. If it's more than that, I have to increase my temperature. So that's the story. So we, as a human, like we have to be careful. The total carbon dioxide won't be more than 2.6 teratons. So, but the thing is, if you look at the slide 92, this is x-axis is our emission per year, y-axis is the year, right? So in order to stop global the temperature rise by 1.5 Celsius degrees, we have to emit in this emit as this blue line. So our emission has to be net zero one day. Can you see that? But if we follow the blue line, we have to be net zero in somewhere around, let's say, 2060. But since we are not following the blue line, but we are on red line, right? If we want to stop the climate change, we have to come very quickly, isn't it? Because we have emitted here already. So now we have to reduce it very quickly, and we have to achieve net zero somewhere around 2014 and 50. I think I hope that you got it. So because
Yes,
then
sir.
only, yeah, then not, because if you follow the blue line only, the total carbon dioxide will be 2.6 tons. Yeah, teratons. Yeah. So this is the challenge. Like, can we, like for me, like it's like a challenge, to be honest. Like, how can we be net zero within like next 20 years? So I can't see any initiation, any plan. Of course, the Paris Agreement is there, but again, we know let's say the main emitters, they are they are not contributing a lot. You know, like the 7 countries, they contribute 70%. USA, for example, they withdrawn Donald Trump, he withdrawn in 2019 from Paris Agreement, but hopefully we think Joe Biden will join the Paris Agreement again.
So, sir, with the time constraints, we need to wind up the session. So, if you have any corrections, you can write them to events.gbcsl@gmail.com. So, thank you very much, Dr. Shanaka, again for sparing your valuable time to enlighten us, and thank you all for participation. So, until we catch up with another event of Green Building Council of Sri Lanka, stay safe and have a good night, everyone.
Thank you so much, Situmini, and thank you very much for again Professor Ranjit Lisanka, and also the council for
Okay.
participants.
Thank you very much, sir, and thank you very much for the participants as well.
Thank you.